Hello, in this video we're going to talk about the difference between inertial reference frames and non-inertial reference frames. And we'll see how that's related to Newton's laws. So, to define, inertial means not accelerating. Now, keep in mind that if an object is rotating, so going around a bend or spinning, that means the direction of its velocity is changing. So rotation requires an acceleration, and rotating systems are not inertial. And boy, is it hard to type and talk at the same time. All right, so hopefully that all makes sense. So let's look at a sketch here to show you in an observable way what the difference is. So we'll compare an inertial reference frame, an example of one, to an example of a non-inertial reference frame. So let's think about a truck driving down the road. So let me try and draw something that kind of resembles a truck. And we'll have the tire sticking out for some reason, but there you go. I guess that kind of looks like a truck. And I want two of these things, so let's try to copy and paste. That'll do. All right, so the first truck, we'll say, is an inertial reference frame. So what that means is the truck might be driving down the road, but it's driving down the road with constant velocity, which means that the acceleration would be 0. Okay, so imagine that there's a ball sitting in the back of this truck, and it's given a little kick. All right, from the point of view of the truck, the direction the ball is going to go is just straight across. It would just roll straight across the truck. If we had some observer sitting down here watching, so say we have a little person sitting down here watching the whole thing, what they would see is that the ball takes a path that looks kind of like this. So it's being carried by it's moving with the truck and it's moving across the truck. So they see it move in a straight line. Okay, now in the non-inertial reference frame, we have the same ball, it's given a kick, but from the point of view of the truck, which is not moving with constant velocity, let's say that the acceleration is positive, so the truck is speeding up. What the truck would see, or somebody in the truck would see, is that the ball seems to bend off to the left. It still goes across the truck, but it's being left behind as the truck accelerates. Now, from the point of view of someone outside, so this little blue person down here, they'd see, well, nothing strange at all. The ball would still seem to go in a straight line. So we have a discrepancy here in the non-inertial reference frame. Somebody in a non-inertial reference frame sees phantom forces. Something has been changing this ball's velocity. It's as if there's some force coming out of nowhere. Whereas in a non-inertial in an inertial reference frame, so this truck or even this person standing still on the ground, everything moves just fine. A constant velocity stays constant. Newton's law is satisfied. Okay, in the next video we'll pick up with Newton's second law. See you in a little bit.